Let there be light. Fire served as man's main source of illumination from the beginning of recorded history until the beginning of the 19th century. Torches, candles, oil lamps, and gas lamps were some of the many methods used to create this light. And then came the humble light bulb. Ever wonder how these are made in factories? Let us tell you. So first up, how are these bulbs produced in factories? We use these bulbs for everything from streetlights, car headlights, and flashlights. You name it. Each bulb has a different size and wattage for use, which affects how much light it emits. We all know that, right? We sure hope so. Light bulbs were first made by hand, but they're almost fully made by machines now. So basically, the filament, bulb, and base are the three fundamental components of all incandescent light bulbs. The process of drawing is used to create the filament. That's always step one. Tungsten and a binder material are combined, and the mixture is forced through a specifically designed vent to create a tiny wire. The wire is then heated during a procedure known as annealing in order to mold it to its right coiled shape, while being wound around a metal rod called a mandrel. The wire is softer and has a more homogeneous structure after this procedure. So next, acid is used to dissolve the mandrel. The lead-in wires are connected to the coiled filament, and the hooks on the ends of the lead-in wires are either squeezed over the filament's end or, in larger bulbs, spot welded. Then a ribbon machine is used to make the glass bulbs or casings. A continuous ribbon of glass that's been heated in a furnace travels along a conveyor belt. Think of an airport's baggage carousel, but it's carrying glass. Thanks to technology, the production of light bulbs is almost entirely automated now. A ribbon machine that can manufacture more than 50,000 lights per hour blows the glass bulbs. Imagine, it used to be done by people. The air inside the bulb is released and an argon-nitrogen mixture is pumped in once the filament and stem assembly is inserted. The base is then sealed in place and voila. But wait, let's talk about the light bulb moment for a second. Old sources of light not only posed the risk of an open flame, but also lacked in providing enough light. The first attempts at creating electric light was done by English chemist Sir Humphrey Davy. Davy demonstrated in 1802 that electric currents could heat tiny metal strips to white heat, producing light. This was the birth of incandescent glowing electric light. The arc light was the following significant innovation. Essentially, this consisted of two electrodes, typically composed of carbon, spaced apart by a little amount of air. An arc of light appeared across the airspace as a result of the electric current flowing from one electrode to the other and through it. Arc lamps or light bulbs were mostly utilized for outside lighting. A significant number of scientists were competing to find a practical source of indoor illumination. Finding sufficient glowing components was the main issue impeding the creation of a commercially successful incandescent lamp. According to Davy, the only metal that could consistently emit white heat was platinum, but when he tried, carbon quickly oxidized in the air. What was needed was to create a vacuum that'd keep the air out of the elements and protect the components that produce light. And then came Edison. We've all heard of this guy. In the 1870s, Thomas A. Edison, a young inventor living in Menlo Park, New Jersey, started developing his own type of electric light. Edison joined the race to develop a reliable electric light source in 1877, first focusing on identifying the causes of his rival's failures. He also realized that platinum was a far superior burner to carbon. After developing a lamp using platinum and receiving his first patent in April 1879, Edison kept looking for an element that could be heated effectively and cheaply. He didn't stop there. Edison experimented with the other parts of the lighting system, creating his own power source and coming up with a groundbreaking wiring scheme that could support multiple lamps burning at once. The creation of a suitable filament was his most significant finding. This wire, which was incredibly thin and thread-like, presented considerable resistance to the flow of electric currents. The majority of the early filaments burned out relatively fast, making these lamps unsuitable for commercial use. To solve this, Edison turned to carbon. After that, his assembly was put inside a glass bulb with a neck fuse, and air was slowly released from the bulb using a vacuum pump. The glass bulb had lead-in wires that would connect to the electrical current. Edison tested his new lamp for the first time on October 19, 1879. It lasted 40 hours without going off, which was a great feat. It goes without saying that this original lamp experienced a number of changes throughout the years. large-scale light bulb production facilities were established, while wiring and electrical current systems saw significant advancements. But compared to Edison's first lights, modern incandescent light bulbs are strikingly similar. The use of tungsten filaments and different gases for improved efficiency and increased illumination are the main variations. The rest we have him to thank for. Anyway, bulb production is a lot of work. Making these bulbs is no walk in the park, not even for the machines in these mega factories. The casings are made by blowing glass through the perforations in the conveyor belt and into molds with precisely aligned air nozzles. More than 50,000 bulbs may be produced every hour on a ribbon machine operating at peak speed. After being blasted, the casings are chilled before being removed from the ribbon machine. After that, silica is applied within the bulb to reduce glare from an exposed, glowing filament. Then each casing's exterior top is imprinted with the firm logo and light bulb wattage. Molds are also used to create the bulb's base, and it's designed with screw-shaped indentations so that it may easily slide into a light fixture's socket. Then, machines connect the filament, base, and bulb together after they've been created. With its ends attached to the two lead-in wires, the filament is first affixed to the stem assembly. A mixture of argon and nitrogen is then injected into the bulb once the air inside has been removed. Why? The gases make the filament last longer. You know when the glass inside bulbs goes black? That's because of tungsten evaporating and crumbling. Bulb wall blackening is the term for the dark deposit that's left behind as it evaporates on the bulb. The bulb and the base are then sealed. No additional material is required to hold the base and glass bulb together because they slip right into one another like two peas in a pod. The two components can instead be held tightly together thanks to their fitting forms, with the lead-in wires touching the aluminum base to ensure appropriate electrical contact. After testing, bulbs are packaged and delivered to customers. And then comes quality control. We're not done yet. Both the lamp life and the strength of light bulbs are examined carefully by experts. Selected bulbs are screwed into life test racks and ignited at levels well beyond their average burning strength in order to produce results quickly. This gives a precise indication of how long the bulb will endure under typical circumstances. All production facilities, as well as a few independent testing facilities, conduct testing as the final step. Depending on wattage, the majority of domestic light bulbs have an average lifespan of 750 to 1,000 hours. Lastly, wondering what's the future for light bulbs? If we're being honest, the incandescent light bulb's future is questionable. Even though heating a filament till it glows is a perfectly adequate method of producing light, it is incredibly inefficient. Over 95% of the electricity provided to a conventional light bulb is turned to heat, not light. This inefficiency may someday render the incandescent light bulb unusable in a world with diminishing resources. When energy conservation is crucial, the light bulb might be replaced with one of the other lighting options already in use. For instance, fluorescent tubes already rule the industrial sector and will surely become more popular as a household light source as well. Compared to these bulbs, fluorescent bulbs use at least 75% less energy and have a 20x longer lifespan. The domestic market for fluorescent lighting may grow as a result of the recent invention of compact fluorescent bulbs, which, unlike the normal fluorescent tube, may screw into a typical household lamp. Also, there's a chance these light bulbs are getting banned. By August 1st, 2023, the majority of incandescent and halogen products will be phased out because in May 2022, the Department of Energy published a new regulation requiring lighting goods to adhere to higher requirements. Then there's good old LED. Other forms of energy-efficient lighting technologies are falling behind LED technology. Future LED lights will be more versatile, less expensive, use less energy, and last longer than current ones. They'll be able to broadcast music, create lights in a variety of colors, and transmit alarms, data, whatnot. But don't forget where it all began, the humble light bulb. That's a wrap for this video. Do you think light bulbs will slowly be phased out of our lives? Let us know in the comments below. As always, don't forget to like this video and subscribe to our channel for more videos like this. See you in the next one.